Yeah, so let us start session. So day one, day two, that introduction completed, our course introduction completed. Yes, Java overview completed. Yeah, today starting, yes, actual subject. Yes, I'm starting subject. Okay, today starting subject. Okay. Yes, starting from the basics. Before going to Java, there are some basics. Okay, before going to Java, there are some basics here. Yes, starting from basics. Starting from basics. Okay, so before going to Java, there are some basics here. Yes, I'm starting from basics. Yes, starting from the basics. Okay, so before going to Java, there are some basics here. Like, yes, operating system, who is basics. Next about interpreter, interpreter and the compiler. Yes, about interpreter and the compiler. Next, about low-level languages and high-level languages. Okay, yes. So about operating system basics, about interpreter, about compiler, low-level language, high-level languages. Next about exe file and dot class file. Okay, there are some software basics here. So before going to Java, there are some basics. Okay, if you good at all these basics, then easy to understand Java. If you good at all these basics, then easy to understand Java. Okay, so let me start with basics here. Let us start with the basics. So let us start with basics here. Software basics, right? Yes. So first of all, yes, computer ware. Computer ware. See, computer ware basically two categories. First one, hardware. Second one, software. Hardware and software. So first one, hardware, and next one, software. So what is hardware? Yeah, this is well known for you. Hardware, these are physical components of a computer. Hardware is a physical components. So these are physical components of a computer like keyboards, mouse, monitor, hard disk, RAM memory. Like there are many things, right? So those are physical components. We can touch all these components here. So next, software. So what is software? Software. See, in software, yes, everything is a program. Everything is a program. Yes, it's a collection of programs. It's a collection. It's a collection of programs. Software is a collection of programs. Okay. So software, it's a collection of programs. All are programs like C programs, C++, okay, maybe Java, maybe OS programs. There are many programs. All these programs comes under software. Okay. So if a software, it's a collection of programs. Software is a collection of programs. Right? Yes, software basically two categories. Software basically, yes, two categories. Software basically two categories. Software basically two categories. So first one, system software. Software basically two categories. First one, yes, system software, and second one, application software. Second one, application software. System software and application software. Okay, right? Yeah. Today starting from the basics. Okay, so previous late Chinese today topic. So last two classes, just only introductions given. Today starting actual subjects. Today starting actual subjects. So before going to Java, there are some basics, software basics. So once these basics are clear, then easy to understand. Okay, today starting from the, yes, starting from basics here. Today actual subject. Last 2 days, just introductions completed. Okay, like your course introduction completed, Java overview completed. Now today starting actual subjects. Today starting actual subject. Today actual subject here, starting from the basics. So before going to Java, there are software basics. There are software basics like OS, next about languages. So next about interpreters, compilers. There are different kind of software basics. Yes, if you good at these all these software basics here, then easy to understand Java. Directly not starting Java. Directly not starting Java. Before going to Java, there are software basics. Software basics. Yes, computerware. Computerware. Computerware basically two categories: hardware and software. Hardware and software. So why starting from the basics means, yes, even without any IT background also you have to understand my Java classes. So first to initially starting the basics here. Okay, then I'll go to actual Java. Okay, right? So computerware. Yeah, there is a hardware and software. Okay. Yeah, these basics, even experts in software fields also don't have knowledge of these basics. Yeah, definitely. Okay, even expert in software field may not have this knowledge. That kind of basics I'll explain here. Okay, software basics. Okay, so hardware. Hardware, these are physical components of a computer. Hardware is a physical components like keyboards, mouse, monitor, hard disk, RAM memory, all the hardware components. So these components we can touch, but not necessary for us. We are not a hardware engineers. We are the software engineers. Let me start with software. Let me start with software. Kya? Software. See, in software, everything is a program. Software, everything is a program. Everything is a program. It's a collection of programs. Software is a collection of programs. Software is a collection of programs like C, C++, Java, OS programs. There are many programs. Software is a collection of programs. Next, software basically two categories. Software basically two categories. First one, system software. Next one, application software. System software, application software. Yes, what is system software? What is application software? Yes, you guys, anyone idea? Yes, maybe already somebody working. Yes. Do you have any idea about system software? Anyone, can you answer this? System software. They're very basics. So started from very basics today. So hardware, leave it. Software. Software basically two categories: system software and application software. What is system software? Anyone idea about it? Of
Windows,
course.
sir.
Yes, tell me.
Windows, Linux, etc.
Yeah, operating systems, right? Operating systems comes under system software. Good, good. Okay. So what is exactly system software? System software, yes, it interacts. It interacts with the hardware components. It interacts with hardware components. So here, system software, it interacts with the hardware components. It interacts with the hardware components. Okay. System software, system software, it interacts with the hardware components. It interacts with components. Yes, hardware components. Best example is operating system. Yes, operating system is an example of system software. OS. All operations like Windows OS, Linux OS, Unix OS, Mac OS, all operating systems comes under system software. I think clear. Okay. See, late join is just 1 minute. I'm repeating today topic. See, last two classes, basics completed. Okay, basics means like not basics, like introductions. Course introduction completed. Wait, course introduction, like about course information only. Next, yesterday just Java were given, but not Java. Okay, today starting subject here. Today starting actual subject. Today starting actual subject. So starting from the basics. So before going to Java, there are some basics. There are some basics, software basics like operating systems, low-level language, high-level language, interpreters and compilers, exe file, dot class file. There are some basics. If you good at all that basics, then easy to understand Java. Easy to understand Java. Yes. So starting from basics, computerware. So here my intention is everyone has to understand. Even without IT background also, my class have to understand. So that's the reason starting from the basics. Computer Computer basically two categories, hardware and software. Hardware, these are physical components of a computer, like keyboard, mouse, monitor, hard disk, RAM memory. Leave it, not necessary for us. We are not a hardware engineers. We are the software engineers. So let us start from the software here. Let us start with software. Okay, software. Yes, in software, everything is a program. Software, everything is a program. It's a collection of programs. Software is a collection of programs. Software is a collection of programs. Yes, software basically two categories. Software basically two categories. So first one, system software. Next one, application software. Software basically two categories. First one, system software. Next one, application software. So what is system software? System software, this one interacts with hardware components. System software interacts with hardware components. Yes, example OS, operating systems like Windows OS, Linux OS, Unix OS, Mac OS, all operating systems comes under this category. Next, application software. So what is application software? See, second one, application software, right? Yes, what is application software? Application software, so this is for the purpose of application development, for the purpose of application development. Okay, so application software, so this is for the purpose of applications. See, apps. In our daily life we are using many applications, right? Yes, in our day-to-day life many applications we are using. So how to develop the such kind of applications? Say applications, for example, WhatsApp, right? So WhatsApp is a most used application. WhatsApp, say Zoom app, right? No, now here using some Zoom app, right? Now we are using some Zoom app. Okay, Zoom app. Yes, next online trading applications, online trading. Yes, the e-commerce applications, online trading apps, food delivery apps. Okay, next Facebook, Insta, Twitter, and all this. Next, banking applications. So banking apps. So all these applications, right? Okay. So how to develop this kind of applications here? How to develop this kind of applications? To develop this kind of applications, we need some software. Okay. So in our daily life, we are using many applications here. Yes, to develop such kind of applications, we need some software. So that software is application software. Yes, application software. Example, best example, Java. Java is a mostly used application software. Java is a mostly used application software. Yes, Java is a mostly used application software. Like C and C++. C and C++. Okay, C and C++. Next, Python is also application software. C .NET is also application software. Yes, even databases also application softwares. Like there are many application softwares. Like there are many languages. See languages. So languages comes under application software. Yeah, there are yes many languages. Okay, so languages, next tools and packages. There are many things like this. Okay, packages, tools and packages. See, there are many languages like Java, C, C++, Python. So like this, there are many languages here. Tools. There are many tools. Okay, many tools like testing tools, data reporting tools, data analytics tools, here AI tools. Okay, yes, how do about big data tools? There are many tools, hundreds of tools nowadays we are using. Packages, package like ERP packages. Okay, so there are many softwares we are using in the market. Yes, more than 100 technologies. Okay, nowadays more than 100, yes, more than 100 technologies we are using, right? So which is exactly application software? There are many things we are using. There are many things we are using, right? See, here system software interacting with hardware components. See, only OS interacting with hardware components. Okay, others cannot. Only OS interacting with hardware components. Others cannot. So except OS, except operating systems, remaining all are application softwares. Except, see, except, yes, except operating systems. Okay, except operating systems. Yes, remaining all are comes under application software. Remaining all are application softwares. Remaining all are application softwares. Remaining are our application softwares. Okay, so except operating systems, remaining are comes under application software. Remaining are application software. Right, whatever software maybe using for testing purpose. Okay, testing softwares, maybe some tools, maybe some language, all are except ways, remaining are our application softwares. See operating systems examples. OS examples. Windows, right? Windows is a OS. So Windows OS. Next Linux OS. Okay, Linux OS. Mac OS. Okay, right? Next Android. Mobile operating systems. Android. Next iOS. Okay. Next Solaris. Like it, there are different operating systems are there. Except this kind of operating systems, remaining all are yes, remaining all are application softwares. Okay. Yes. Right? So except operating systems, except these kind of things like Windows, Linux, Mac, these things, except this remaining are so whatever these softwares we are using, yes, so whatever these softwares we are using, many softwares we are using nowadays here, hundreds of technologies, okay, hundreds of technologies. So except these things, remaining all are except these things, remaining all are application software. Except these things, remaining all are application softwares. Clear? Okay, fine. Now, so what is Java? Yes, let me show you a today class document. So you guys, running notes is not necessary. Running notes is not necessary. Just you can follow this document here. This document for you only. So this document for you only, I'll share with you. Okay. Yes, introduction to software. Software is a collection of programs. Next, software basically two categories. Software basically two categories. First one, system software and then application software. System software, it interacts with hardware components. Example ways, right? Same thing it's there in document here. I have prepared very clearly in document here. Just you follow this document here. So running notes is not necessary. I request everyone to focus on the class. Okay, try to understand the class, watch it here. Try to understand class. Don't write any running notes. Don't deviate. Just you focus on the class. Try to understand class. Okay. Yes. So it is system software, next application software. See, for the purpose of application development, yeah, this kind of applications, right, apps. Example, application software example, C, Java and all these, right? Next, except operating systems, remaining all are application softwares. I hope you understanding is right. Okay, so try to understand. Okay, so like a spoon feeding, every topic I have prepared. So each and every line very clearly prepared. Okay. So system software and application software. Right? Now what is Java? Java comes under what? System software, application software. So what is Java? What do you understand from this here? What is Java? System software, application software. Hello. Anyone please respond. So what is Java? System software, application software. Yes, no one responding. What's happening? Yes, application software, see that. Java, right? Java is application software. Java comes under application software. Java is a application software. So our topic is about application software. Topic is about application software. So before going to application software, before going to this application software, let us see something about OS. Operating. What is exactly OS? Let us see something about OS. Yes. Yes. So what is OS here? So what is OS? Here, some question for you guys. Some question. Some question. Can we run any program? So without OS. Very simple question. Yes. Anyone can you answer this? Yes. Can we run any program without OS?
Without OS, we can't run any program.
Can't run, right? Yeah, fine, good. No. Answer is no. If no voice, first of all, no computer. Without voice, no computer. Yes, if no voice, no computer. Without voice, we can't. Okay, so we can't. So can we run any program without voice? No. Answer is no. No, we can't run. If no voice, no computer. No voice, no computer. See, except, except, see, except bias. Except bias. Yes, bias is a hardware program. Bias program. So bias, this is a bias program. It's a hardware, that is not a software program. Except bias to run all software programs who is required. Software programs who is required here. Who is required. Who is required. So except bias. So except bias, sorry. See, except bias to run all software programs. Yes, voice required compulsory. Without voice, we can't do anything here, right? Yes, what is exactly bias? Yes, anyone can you abbreviate? What is bias? Abbreviation. Just I'm asking only abbreviation. Bias. Anyone idea? What is bias? Yes, bias stands for basic, yes, input and output system. So bias stands for basic input output system. So bias stands for basic input output system. So here bias. See here bias is a hardware program, is not a software. So bias is a hardware. It's a hardware program. Okay. Yes, it is a chip level program. It's a chip level bias. It's a chip level program. Let me show this bias in your system. Yes, bias. Bias. See here, this is bias. Yes, here this is bias, right? Bias. So bias is a hard, it's a chip, bias chip. In motherboard, this is a bias chip. Okay, right? So what's the task of this bias? What's the task? What it will do here? So when you power on your system, so once you power on system, first of all, power goes to bias. Now this bias program, this bias is responsible to boot your OS. So bias is responsible to boot operating system. So your bias. So your bias is responsible to boot operating system. So your bias. So bias is responsible. So bias is responsible to boot operating system here. So bias is responsible. Bias is responsible to boot operating system. To boot operating system. So your bias is responsible. So your bias is responsible for booting operating system. What is booting process here? So your bias is responsible to boot OS. So what is booting? See, yes, OS in the disk, hard disk, right? So what is hard disk is for the storage. Hard disk is for the storage. So here hard disk is for the storage, right? Hard disk. So hard disk. See, inside of C drive, there is a OS. Windows. So here it's a Windows OS, right? Windows OS inside the disk. Here is C drive. In C drive, Windows OS is there. In C drive, there is a Windows OS. In C drive, Windows OS, right? So this Windows OS stored in C drive. So once you power on system, here, yes, simply BIOS program will load this Windows OS from hard disk to RAM memory. Hard disk and RAM memory. Hard disk is for the storage, RAM is to run the OS and other programs. Okay, hard disk is for the storage. Next, OS running inside the RAM memory. See, these Windows OS, right? Yeah, this OS running inside the RAM memory. So here it's a OS. Windows OS running in the RAM memory. See, everything running in the RAM memory only here. Okay, even Zoom application. Zoom application. Okay, so Zoom application. Yes, Word documents. Okay, maybe browser. So maybe some notepads. All are running. Yes, inside the RAM memory. Okay, so RAM is to run the OS and programs here. OS and all the programs. So hard disk is for storage. Hard disk and RAM memory. So hard disk is for the storage purpose. RAM is to run all the programs. All programs, right? So once your system started, so once you power on system, power goes to BIOS. So this BIOS is responsible. This BIOS is responsible to boot OS. Booting. So what is booting process? So booting is a process of yes loading OS from hard disk to RAM memory. So booting is a process of loading OS from hard disk to RAM memory. See here, this Windows OS running inside the RAM memory. So yes, running in RAM memory, right? So initially BIOS. So once you power on system, first BIOS program starts. So when power on system, first of all BIOS starts. Okay, right? So this BIOS. So BIOS is responsible to boot operation. So what is booting here? See booting. Yes, booting is a process of loading. Yes, loading. Yes, loading OS from hard disk to RAM memory, hard disk to RAM, hard disk to RAM. That's it. That's all about BIOS here. Very simple, right? So BIOS stands for basic input output system, basic input and output system. So BIOS is a hardware program. It's a hardware. It's a chip level program. So BIOS is responsible to boot operating system. BIOS is responsible to boot OS. What is booting here? Booting is a process of loading OS from hard disk to RAM memory. Now it's loaded. Now OS is running, correct? Yes, this Windows OS. This Windows OS running in the RAM memory. This Windows OS running in the RAM memory. That's all about BIOS. Now let us come to OS here. So what is exactly OS? Yes, about OS. Let us say about OS. So what is operating system? So what is operating system? Yes, what is OS? Question is what is operating system? So what is operating system? Let me explain clearly here. So what is OS? See your computer. Yes, so this is your computer. Okay. In computer, there are different layers here. So first, there is a hardware layer. Okay. There are hardware components. There are hardware components. Hardware components. Okay. On top of hardware components, here who is running? Operating system. Operating system running. So here it's a hardware components. On top of hardware, yes, who is running? Who is running, right? Yes, on top of which all programs running here. Maybe C program. Yes, C++ program. Yes, C program. Yes, C++. Sorry, C++. Yes, maybe Java program. Okay, maybe databases. Yes, maybe Python. Python. All are running on top of OS here. Python. Yes, maybe databases. Databases. Okay, even for MS Office also is required. Yes, MS Office also is required. See, all are running on top of OS. Okay, all the programs, maybe C program, C++, Java, Python, all programs, everything running on top of OS. Okay, see these all are what application softwares. Yes, application. Yes, application. Yes, software. Yes, it's a application software. Application software. So all application softwares. Yes, all these application softwares running on top of OS. So here it's a hardware components. On top of hardware components, there is a OS here. On top of OS, all application softwares running. Okay, right? Here there is a hardware components. Next OS. On top of OS, all the application softwares running. Clear? Yes. See, OS is a system software, right? OS is a system software. OS is a system software. Okay, OS is system software. This whole thing is computer. This whole thing is a computer. That computerware. That whole thing is computerware. See, computerware. Previously, we have discussed computerware, hardware and software. Computerware, hardware and software, right? Hardware and software. See, hardware layer, and these two are software layers. This whole thing is computerware, hardware, and then these two layers software. Software. See, in software, yes, system software and application software, right? Software, system software, and application software. See this here. Yes, here the system software layer, on top of it, application software. So this whole thing is computer aware. In computer aware, yes, hardware and then software. In software, two categories like system software and application software. That's it. Fine. Okay, right? Yes. Now, let us say about OS. See, on top of OS, all programs running, right? On top of OS. On top of OS, all the programs running. That means, yes, OS is giving platform. OS just is giving platform. So acting like a platform. So on top of OS, all are running, right? So what is OS here? So it's a platform. So OS, yes, it's a platform. It's a platform. Yes, it's a platform. Yes, it's a platform. It's a platform. Yes, where we can run, yes, all application softwares, where we can run all, yes, application softwares. Okay. Yes. So what is our prediction? Simple answer. What is OS? It's a platform. So OS is a platform. So OS is a platform where we can run all application softwares. It's a platform. So OS acting like a platform. It's a platform where we can run all application softwares. Yes. So anyone asking question, what is OS means? Simple answer. It's a platform to run all application softwares. Okay, so OS is acting like a platform and on top of it all are running here. Yes, any application running on top of OS only here. Any application running on top of OS. See here, Zoom application running on top of OS. Zoom app running on top of OS. See, this Word document running on top of OS. Okay, right? Yes, this notepad also running on top of OS. Even browser also running on top of OS here. So all are running on top of OS only. Everything will be running on top of OS. That application may be anyone, whatever it is, all are running on top of OS, right? So it's a platform, right? See, not only platform here, not only platform, not only platform. Suppose sometimes, yes, some of these programs generating some data, application softwares generating data. The data first of all transfer to OS. Okay, so output of all these application softwares, first of all transfer to OS. After transfer to OS, finally deliver to output device. Okay, so here output of all these application softwares, first of all transfer to OS and then deliver to output device, maybe screen. For example, reading from keyboard, data reading from the keyboard, that keyboard hardware, right? Keyboard data first of all goes to OS. Keyboard data transfer to OS. Okay, and then taken by the application softwares. Okay, so keyboard to OS, OS to application software. Next, vice versa. Application software to OS, OS to output device. So between application software and hardware components, there is a OS. So it's a middle layer, like a mediator, means interface. So OS is acting like a interface. It's acting like interface. Okay, it is an interface. So OS, yes, it is an interface. Yes, it is an interface. OS, it is an interface. Yes, it's an interface. OS, it's an interface. Yes, between, yes, application software. OS, it's an interface between application software, application software, and and hardware components. Application software layer and hardware components. Yeah, that's all about OS. So what is OS means? It's a platform. Okay, it's a platform to run all software programs. It's a platform to run the software, right? Next, one more thing, it's acting like interface. Interface between the application softwares and hardware components, right? Yes, one more point. Yes, Java perspective. Okay, for Java perspective here. Yes, in OS there is a library. Library. So every OS. So every OS there is library. In OS there is a library. Yes, OS there is a library. That library contains input-output functions. Input-output functions. Input-output functions. Library contains input-output functions here. Yes, every OS there is a library. So this library is responsible. In every OS there is a library. So that library is responsible to perform IO operations between application software and hardware components. Remember this point here is useful point for the Java. Yes, every OS, see every OS has, yes, its own library, has its own library. Every OS has its own library. Yes, to perform, yes, input and output operations. Yes, input and yes, output operations. Okay, so every OS has its own library to perform IO operations, input and output operations. Yes, between, yes, between, yes, application software and hardware components. So inside of OS there is a library. So this library is responsible to perform IO operations between application software and hardware components. Clear? Next, one more point here. See, maybe C program, C++, Java, these programs, right? So what happens here? First of all, these programs linking with OS library. So before going to run the program, any program before going to run it here, first linking with OS library, that library linking with hardware components. Okay. See here what happens here. So when OS started, so once OS started here, OS started, yes, instead of OS library, that library links with hardware components. So between library and hardware components, already channel establishing channel to transfer data. So when OS booted, yes, between library, hardware components, the channel creates. Next, these programs. So before going to run these programs, here, so first of all, yes, linking with library, right? So here, so these programs linking with library, that library already linked with the hardware components. So between these programs and the hardware, the channel establishing, then program working here. So before going to run any program, so first of all linking with OS library, then executes. That link may be statically linking or dynamically linking. Statically, dynamically, later I will explain. What is static link? What is dynamic link? Later I will explain here. Okay. So every program here, every program. Okay, that may be C program or C++, Java, something like this. So every program has to link with OS library. OS library before going to run it here. Before going to run it here. Before going to run it here. Yes, try to remember this last point here. Last point, Java perspective, most important this is. Yes, every program has to link with OS library, before going to run it. So that's all about OS. So what is operating system? It's a platform. Next, an interface, right? Next, it can is library. So every program has to link with OS library before going to run it here. That's all about OS. Same thing explained in document also. See the document here. Let me show the document. See introduction to software. Same that introduction, right? Same point. All points are mentioned document here. I have prepared very clearly just to follow this. About OS. Okay. Same that question. Next about bias. Okay. Next about operating system. These 4 points, right? Okay. See hardware. On top of hardware. OS. On top of OS. Application software. Here everything clearly mentioned. In documents, I have prepared everything clearly. Okay, just you can follow document here. So running notes is not necessary, just you follow document here. Okay, just read the document after finishing class, read the document, then easy to understand. You can remember. Yes, if you're reading immediately, then easy to remember. Okay, fine. Now, so this is about OS. Fine. So Java is application software, right? Java is application software. Now let us move to application software. Let us move to application software. Java is application software. So application software. In application software, there are two things again here. There are two things like front end and back end. In application software, yeah, there's a front end software and back end software. So what is Java? Front end, back end. Let me explain clearly. What is Java? Is it front end or back end? Let me explain here. See, this is web application. Web application architecture. application which is running on the internet. Application which is running on the internet is web application. Yes, in web application architecture, here this is a front end. Next back end, right? So what is front end? It's a browser environment. Front end is a browser environment. Right? So front end is a browser, right? Browser environment. So for example, here, see browser, yes, some registration form, right? Yeah, today submitted this information, right? It's a registration form. Here submitted your information, right? This is front end. So this is the front end. The browser environment is a front end. Browser environment is a front end. It's a front end. Front end, right? Yes, your registration data. Simply your registration data. So first of all, posting to backend. At the backend, some applications, maybe Java application, .NET application, Python, different kind of applications. So these applications taking data, inserting database, and reverse, vice versa, taking from fetching data from database and present to browser, right? Like this, vice versa, like this. This happens. Okay, so front end to this front end to backend application database. Now reverse backend database to application browser, right? So this is what is happening in web application. See, here Java comes here, right? Java here. So what is Java? Java is a backend application software. I think yes. Java is a backend application software. Okay, to develop the backend applications here. Okay, see, front end, yes, is a client. Front end called as client. Backend is a server. Client and server. Client and server. Yes, Java. See, Java is a backend software. Java is a backend software to develop server-side applications. Okay, Java is a backend software. See here, this is JavaScript. JavaScript different, Java different, not same. JavaScript, Java, not same. They're different kind of things. JavaScript, Java, not same. JavaScript at the client side, Java at the server side working. JavaScript works in the browser environment. Java with JVM. Okay, Java inside the JVM. But JavaScript is browser. That's it here. Not same. So JavaScript at the client side, Java at the server side. Okay, same thing is in document here. Just you follow document here, right? Yes. Next, front end, back end. In front and back end, there are two things: languages and packages. Languages and packages. Okay, see in packages, package ready-made one, ready to use. Package ready-made one, ready to use. Like MS Office, it's a package. Yes, ERPs, it's a package. No coding. In packages, no coding. So need not write any coding. Directly in this package. So when come to languages, here is a coding, right? Programming and coding, right? Okay, so Java comes under languages. Okay, Java is a language. Java is a backend language. Java is a backend software. So it's a backend language. Java comes under languages, right? Yes. Now let us say about languages here. Yes. See, software languages. See, there are two things. See, we are understanding some language, computer understanding different language, right? Our language different, computer understandable language different, right? Yes. So computer understandable language. Computer, yes, computer understandable language. Computer understandable language. Computer understandable language. And next, we are understanding some language that is user understandable. Computer understandable language and user, yes, understandable. User understandable language. So computer understandable language, user understandable language. Okay. So computer understandable language and next user understandable language. So what is computer understandable language? See, computer understandable language. Computer understandable language, it depends on generation of computers. It depends. It depends on generation. Generation of computers. It depends on generation of computers. Here, one more question for you guys. One more question. One more question. Yes. How many generation of computers? How many generation of computers? How many generations? How many generations of computers? Anyone idea? Just check in Google. Online, yes, you are in online rates. Yes. How many generation of computers? Yes, answer. Yes, just to check in Google, you can see how many generation of computers. Yes, anyone can you answer? How many generation of computers? You have the Google, search in Google. No one? Okay, fine. I'll explain. How many generation of computers? Yes, there are 5 generations. There are 5 generations. There are 5 generations. Yes, first gen. What is first generation computer? Yes, anyone electronics background. Yes, anyone electronics background, please respond. What is first generation computer? Yes, vacuum tubes. First generation computer, vacuum tubes. First generation is a vacuum tubes. Yes, second generation. So what is second generation computer? Second generation computer. Yes, transistor based. Yes, transistors based. Right. So first generation vacuum tubes. Second generation transistors based. Next, third gen. So what is third generation computer? IC based. IC means integrated circuits. IC means integrated circuits. IC based. IC based. Right. Next, fourth gen computer. So what is fourth gen computer? It's a processor based. It's a processor processor based computer. Yes, processor. It's a present generation. So this is present generation. So processor. It's a present generation computer. Present generation computer. Right. Next, fifth gen. Fifth gen. Yes, it's a feature. Tell me what is feature computer? Presently we are using processor based computer. Present generation. Presently we are using processor based. What is feature computer? Fifth generation is a feature computer. Yes, what is feature computer? Anyone idea? What is feature computer?
Intelligence, sir.
Yeah, good. Yes, AI. AI based artificial intelligence. Now this is feature. Yes, feature computer. Feature, right? Now presently we are using processor based computer. Yes. So what is processor based understandable language? Processor based computer. Processor based. Yes, computer understandable language. Understandable language. So what is processor based computer understandable language? Yes, it's a binary code, right? Binary format. Yes, processor, microprocessor understandable language. Okay. Yes. So processor based computer understandable language is binary code. Binary, binary codes. So binary code is like a zeros ones format. Binary codes. Yes, zeros ones format. Zeros ones format. It's a binary code. Yes, how that binary code is generating, the topic we'll discuss. Okay. Yes, once Java started, that time I'll explain here. Okay, maybe tomorrow, day after tomorrow, starting Java. Okay. Yes, binary code. Yes, zeros and ones. So how that binary code generating, how it is converting into binary code, the topic we'll discuss. Next coming topic. Okay, fine. Okay. So processor based computer understandable language binary code is a binary code, right? Next. So what is AI based computer understandable language? Yes, AI. AI based computer understandable language is anyone? Yes, AI based computer understandable language is anyone? What is AI based computer understandable language? English. Just it can understand our English like a human. Yes, AI works like a human being. So AI based computer understandable language English. Okay. Yes, it can understand English. AI based computers can understand your English. Okay. Yes, you saying something. It can understand your English here. So what is exactly AI? See, artificial intelligence, it's a technology. Just it's a technology. Technology to make machines. Machines, yes, working like a human. Working like a human without human intervention. Yes, exactly like a human, but no human involvement. Without human intervention here. So AI is a technology to make machines working like a human without human intervention. Same exact like human. Okay, but no human involving, no people involving here without human intervention. That is AI technology here. Right? So AI technology to make machines work like a human without human intervention. Okay. See, for example, here, yes, in your home, there is a AI device. For example, AI device, some AI device. Okay, in your home, suppose any AI device. So whatever you says, it can understand it. It will respond to you. Okay. Yes, suppose your home, yes, automated with AI. So whatever you says, it can understand it, your English. Okay. Suppose in your home, yes, suppose lights off, on, fan off, on, like Alexa. Alexa, right? Alexa is something like a AI example here. AI-based device. Okay. So this AI device can understand our English. So what are you saying? English it can understand. For AI-based machine, yeah, that input data can be like this text data or voice data. See, you guys are, yes, able to read this data, right? Text, you able to read this text data. So you understanding text data and also my voice data, right? So AI is not exact like a human. Okay, so you see this. AI can read text data, this kind of text data, and can understand, can listen for voice. So like a human. So you guys, yes, able to read all this text data. You understanding text data at the same time understanding my voice also. That's it. AI exactly same. Okay, so same like a human. It can understand. It can take text data, voice data, any data. It can take any data. So it can take any data, it will remember everything. Suppose you say any story about your family, your ancestors, suppose about your today task, okay, maybe some stories. That AI device, yes, will understand your stories, will listen for stories and keeping it in memory. If you're asking any question, it will respond. Yes, for that question, yes, you search for that answer and giving answer, right? Okay. So here in your home, if a device is available, see, you need not to feel lonely. Suppose you're only one person, then need not to feel lonely here. You can talk to a device, chatting with a devices. Okay, you say something that will respond. You say something that will respond immediately. Like that, you can chat with a device. Okay, next, one more example, Tesla car. Yeah. Tesla car, it's a AI-based car, right? Yes, US and China, they are using these cars, right? Tesla cars, AI-based cars, driverless car, driverless car. Okay, so once route defined. So Tesla car integrating with mobile. Tesla car once integrating with the mobile here. So whatever instruction says in mobile, it will listen, it will perform the task. Yes, without driver, yes, without driver, it go to some location here, some destination, picking some persons or picking some material, whatever you want. Okay, without driverless car. So that AI device working like a driver, right? Like a driver. Okay, like your family member. Okay, right? Yes, like a driver, like a family member. Suppose, for example, here, yes, healthcare system, health health monitoring devices, right? Yes, nowadays, yes, yes, most of the people using, yes, watch, right? Watch, that wristwatch, AI-based wristwatch to monitor our health, right? I'm using that watch already. AI-based wristwatch I'm using. Okay, that will monitor my health. So minute to minute, it gives the results. What is my heartbeat rating, my pulse rate? Okay, next, how many steps I have to walk? Okay, next, ECG, and every information that shows here. Okay, that monitoring like a doctor. Okay, So you can like a yes, that AI machines like a yes, like your family member, like your friends, like a like a driver, like a doctor, okay, even like a yes, software engineers. That AI devices generate some code also. If you're asking some code, generating some code. Yes, take that code, you have to customize that code and build the application, right? So like a software engineer, that AI-based machines working like a, the tools working like a software engineer, right? Yes, even yes, manufacturing industry, okay, like a workers. That machines working like a workers here, okay, like a civil engineer. Yes, everything, wherever human intervention, okay, right? Yes, there AI we can use. Okay, right? Yes, all professions, even teaching professionals, AI tools will do that. Okay, suppose if you choosing any topic here, yes, that will explain automatically. Okay, like a teacher, like a doctor, like a driver, like a software engineer, like a civil engineer, like a mechanical engineer, every profession AI will do. Okay, right? AI will do. That is exactly AI. Okay, fine. Okay, so it's a feature. AI, right? Yes, even AI comes, no loss of jobs. Reason, yes, lot of population in the world. Lot of population. Currently, 8 billions of population is there. AI maybe by 2030 AI comes. By that time, population reaching to 1100 or 1200 crores. 8 billions means 800 crores. Okay, by 2030, maybe 1100 crores. To serve that much of people, compulsory that AI required. Otherwise, cannot meet the requirements of that much of population. Okay, see, in 90s periods, see, in 1990, yes, I'll tell you one analysis here. In 1990, how many world population? Just only 100 CR, 1 billion of population, right? That time we don't have this much of technology, right? Yes. So like this, every 10 years that population growing rate, yes, maybe 2000 year, around 200 crores of population. Okay, population growing. Okay, technology also improving here. Suppose if technology not improved, okay, same 1990 technology using 2000, it's highly impossible to meet 200 crores of people. Yes, highly impossible, right? So when come to 2010, yes, 2010, the census every 10 years, right? 2010, yes, in 2010, yes, around 400 crores of population is there. 2010, around 400 crores, right? By 2010, lot of technology improved. Smartphones, okay, and many applications came to market, right? Okay, so with that, yes, able to meet the requirements of 400 crores, right? Population increasing, but technology has to increase, right? Population increasing, but no technology increasing. Then what happens? Highly impossible to meet the requirements of 400 crores of people here. Highly impossible. Okay, even technology improving, no loss of jobs. No loss of jobs. Yes, suppose 2000 year, if computer comes, loss of many jobs. That time talk was like that. But there are many jobs created. Even computers came, even software came. Yes, many lot of jobs were created. Okay, right? So because of population increasing, so 2020 population, yes, around 700 crores of population 2020. Okay, around 700 crores, right? So 2020. So by the time of this 2020, lot of social media increase, right? Social media, lot of technologies and fast. Okay, network speed. So many things improve. Lot of technology, right? Okay. Yes, with the technology, yes, able to solve the requirements of the 700 crores of people. That population increasing, at the same time, technology increasing. If technology is not improved, then what happens here? It's highly impossible to serve 700 crores, right? Now 2025. Now what is current population here? 850 crores of population. 850 crores of population. Okay, 2025, 850 crores. Yes, to meet the requirements of 850 crores of people. So compulsory technology has to improve here. Compulsory. Suppose when come to 2030, okay, 2030. Yes, maybe the population around 1100 crores, right? 1100 crores of population. Yes. So to meet the requirements of 1100 crores of population, currently technology not enough. Yes, highly impossible. So current technology is not enough here to meet the requirements of this much of population. So compulsory some new technology required. That new technology is AI. AI. Okay. So yes, if AI comes, yes, then meeting requirements of this much of population. Otherwise, highly impossible to meet the requirements of the right. Even AI comes, many jobs creates. Don't fear about AI here. No threat from the AI. Okay, the AI creating many jobs. No doubt, AI creating many jobs. One more thing I'll tell you. Yes, in 1990, to build an application, it was taken for 2 years. Yes, see, since 1993, I'm in the software field. Yes, I'm in software field. Yes, since 1993. So 1993. See, my engineering. Yes, 1993 to yes 1997. My engineering. Okay, engineering. Yes, computer science. Okay. Yes, BTech computer science, CSE. So 93 to 97 completed. Since 1993, I have the software awareness. Since 1993, I have software awareness. So what I observed since 1993 today. See, 1990, yes, it was taken 2 years to finish any project. Yes, any project was taken 2 years because of very less technology is there that time. Yes, when come to 2000 year, yes, it was reduced to 1 year. 1 year. Okay. So 2000 year, 1 year. Project completion 1 year because of improvement in technology. So when you come to 2010, yes, it's taken for yes 6 months. 2010, 6 months finishing projects. 2010, every 10 years, technology improving, population improving. To meet that requirements, yes, applications has to build in short time, short time, right? When come to 2020, 2020, yes, yes, 3 to 6 months, max 6 months, 3 to 6 months. Yes, 3 to 6 months. See, in the year 2017, in the year 2017, yes, we build an application within 1 month. Just 1 month only we build some GST application. Yes, 2017, GST came. Central government applied GST. Yes, within 1 month we finished that application. Okay, because of the technology here, Google is available. So there are many, yes, uh, coding generate tools available, right? So with the help of that, we are able to finish, yes, within 1 month only. Yes, nowadays, yes, 3 to 6 months. Now 2023, 2025. Yes, within 1 month we are finishing applications. Now clients are asking to finish application within 1 month only. No client giving time. No client giving time. They're asking to give the application within 1 month only. Even some clients are asking to finish within 1 week. Ready-made product. They're asking for ready-made products. See, there are lot of e-commerce happening, right? In market, lot of e-commerce happening. So there are many e-commerce, yes, thousands of e-commerce applications are there. Thousands. Okay. Yes, even not thousand, lakhs of e-commerce applications. Yes, how we are able to develop lakhs of e-commerce applications? Just we are customizing existing e-commerce application. Already we are already we have some e-commerce application. Just we are customizing as per client requirements. We are delivering within 1 month. So 1 month only we are delivering. Some clients even asking within 1 week also. See, so by the period 2035, what happens here? Application time to build the application time just only 1 hour. Ready-made applications. 1 hour, even 10 minutes. So 1 hour, even 10 minutes also, you are customizing application giving to customer clients here. So 10 minutes. Okay, by 2035. So every day many applications required. Okay, see, presently here, see, DMart, right? In DMart, yes, we are purchasing groceries, right? Groceries. Yes, by 2035, it becomes like a DMart. Yes, simply go to shop and purchasing application installing in our device. Go to shop, purchasing application and installing your device and using that, right? See, DMart. we are purchasing groceries, right? That groceries. Yes. Yes, that groceries may be for 1 month or 1 week, right? Okay. That groceries, right? So maybe 1 month, 1 week using that groceries, right? Yes, still we need some more groceries, like continuously requirement, right? Same applications also like that only here. Going forward by 2035, okay, 1 week applications, okay, that 1 week applications, 1 month some application may be using for 1 month. After 1 month, yes, maybe updated version will come. Yes, reinstalling application, right? So purchasing application like a groceries in DMart, a situation becomes like this. Okay, every 10 minutes, every 5 minutes applications purchasing, right? Continuously purchase like a DMart. Yes, applications purchasing like a DMart. Okay, right? To meet that requirements, how much? Yes, how much manpower requires? Yes, this manpower may not enough. By 2035, currently manpower is may not be enough. Compulsory new technology required to meet that requirements. That is AI. That is AI, right? See, so when you meeting in 2035, yes, suppose if we meeting in 2035, definitely we'll repeat this one. Yes, sir. Yes, our Java sir, MN Rao sir, that day said same thing happened today. Definitely we'll see that. Okay, just you write in our diary, just note in our diary that will happen 2035. I'm sure that is my analysis. So what I observed since 1990 today, what I observed. Okay. Yes. 2 years project, 1 year project, 6 months project. Yes, 1 month project, 10 months project, 10 minutes project within 1 minute. Okay. Yes, that application may be using for 1 week. Uninstalling a new application, maybe 1 month application, 1 week application, 6 months applications. Okay. So upgrading applications, right? Every time that require. So something like a grocery stores. Okay, you have to purchase in future purchasing application like a grocery stores. That's it here. So to meet that kind of requirements, compulsory we need AI. Yes, if don't have AI, definitely the system fails. Worldwide system fails. Yes, we can't survive. So by 2035 minutes, maybe population around 1300 crores, 13 to 1500 crores. We can't say. Lot of population increasing. 13 to 1500 crores. Suppose if population is 1500 crores, to meet the requirements of 1500 crores, current technology is not enough. Definitely the system will fail. World system will fail here. Okay, also like banking system fails, e-commerce system fails, every system fails if AI not comes. Okay, with AI we can overcome that requirement. That is advantage of AI. Even AI comes, jobs will increase. Always jobs demand is there. So to meet that requirement, definitely AI required. If you don't have AI, definitely that complete system fails. Okay, I hope you understand, right? Yes. So don't no threat from the AI. Even AI comes, yes, it will create lot of jobs. Okay. Yes. Yes. So even AI comes, lot of jobs comes here. So no worry about yes AI. No threat from the AI. Yes, even learning AI also very simple. Learning AI is simple compared to Java and all that. AI is very simple. Okay, so that's all about AI. Fine. Okay. Yes. So there are different generation of computers. You can see. So computer, yes, computer understandable language. Binary code. Now presently we are using processor understandable language. Processor understandable language, binary code, right? This is called as low level language. Yeah, this is called as low level language. So first one, yes, low level language. Second one, user understandable. It's a high level language. High level language. Low level language and high level language. Low level language and high level language. Yes. Low level language. Low level language. Yes, it's a yes, system understandable language. System understandable. System understandable. System understandable language. It's a system understandable language. It's a system understandable language. Understandable. Yes, it's a system. understandable language, right? Yes, it is in binary. System is processor here. System is processor. Yes, it is a binary code. It is a binary code. Binary code, right? Yes, it is called as machine language. Yes, it is called as machine language. It is called as machine language. It is called as machine language. So next, high level language. High level language. Yes, it's a user understandable language. Yes, it is a user understandable. Yes, understandable. User understandable language. Yes, it's a user understandable language. User understandable language. Yes, it's like English. It's like a English. User understandable language. Yes, English, right? Yes, example. High level language example. Java. Java is high level language. Next, C and C++. C and C++ are high level language. Python is high level language, right? So these whatever the programming we are writing, all programs are high level language. High level language, right? So we are writing this high level language programming, right? That looks like English language. Java program, C++, Python, all are like a English language. 1 second. All are like English language. Yeah, that English language, high level language has to convert into binary code. Okay. System understandable language. Binary code, right? Yes, binary code, zeros ones format. Every high level language program. Yes, every high level language program has to, yes, has to convert into binary code to understand system, right? System has to understand it. System has to understand it. Okay, yes. Yes, 19 before 90s period also CSE is there, computer science engineering, JNTU, JNTU Hyderabad. Yes, Sambi Singh. Before 1990 also computer science is there, JNTU Hyderabad, my engineering. Okay, yeah. So high level language program has to convert into binary codes. So to convert it here, yes, either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler to convert from high level language to binary codes. Okay, yes, right. So interpreter or compiler. Say what is interpreter, what is compiler? Interpreter and compiler both are to convert into binary code only, but some difference is there. So what is the difference? Yes, about interpreter and compiler topic. Tomorrow we'll discuss about topic interpreter versus compiler. So tomorrow topic interpreter versus compiler. Just a minute. See today topic. Yes, everything is there in the program in the document here. Just you can follow document here. Yeah, this document will be sharing. Okay. Yes, tomorrow I'll give the drive access. Yes, all the videos, documentation, I'll put in a drive. Tomorrow I'll give the drive access for every student. Drive access for every paid student. For all paid students, tomorrow drive access will be given. Tomorrow drive access will be given. Okay. Yes. Right. Yeah. So tomorrow definitely drive access. Yes. If anyone, yes, not with, please try to pay the fees. Tomorrow will get the drive access. Of course, tomorrow also same link, demo link only. Yes, on the request of students, just one more day extended. One more day. Okay. So from Friday, it's a paid link. Tomorrow also same demo link only. Please try to finish your payment if possible. Try to finish your payment by tomorrow class. So I'll give the drive access. Drive access to videos, documents, and softwares. So try to finish your payments. If not, max, yes, Friday evening. So Friday it will be, yes, paid link. So tomorrow one more day is the demo. That's it. On request only, just on one more day extended. So tomorrow also demo link. Okay, Friday onwards is a paid link. Okay, fine. Yes, these are the topics. Today's topics. All these topics complete here. Tomorrow, yes, interpreter versus compiler. Tomorrow topic. Then, yes, starting Java, introduction Java. So tomorrow I'll be giving introduction to Java. Yeah, that's all for today. Any doubts? Any doubts? Yeah, definitely day by day getting interested. Yes, my topics day by day getting interest in depth I will cover. Okay. Yes, any doubts? Still any doubts? Yes, if no doubts, let us wind up session for today. Right? Tomorrow, same link, same time. So no changing time, of course. Only link. Tomorrow, same link. From Friday, changing link. So thank you, guys. Yes, I have another session. Yes, after your session, one more session is there. I have to take that session. The guys are waiting. Yeah. Thank you, guys. See you tomorrow. Have a great night.